before we begin, let's do a quick review. What are the factors of 4? Smith.
1 and 4 and 2.
1 and 4 and 2. Those are the factors of 4. That's what we did the other day. We did greatest common factor. So we had to list the factors of two numbers and find the biggest one that they both had in common, the greatest common factor. What about the multiples of 4? We're going to not worry about 0. Multiples of 4. Carla, what's the first multiple of 4 other than 0?
1.
Not 1. This is where the problem is. We've done like a bunch of lessons on factors and multiples, and you're still confusing them. They are two different things. Carla, try again. The first multiple of 4 other than 0. Okay, who can tell Carla what is a multiple? What is a multiple? Come on, guys. Colin, what's a multiple?
A multiple is
Loudly.
a multiple is an answer to a multiplication problem.
That's a product. The product is the answer to a multiplication problem. What is a multiple? Victoria? Okay, this is the issue. We've done several lessons on factors and multiples. Factors are the numbers you multiply together to get a certain number. Multiples are the answers to multiplication problems using a specific number. So the products of multiplication problems using a specific number. So Carla, what is the first multiple of 4 other than 0? Because we're not worried about 0.
4.
4. List the first 5 for me. So we have 1, the next one.
8.
Next one.
12.
Next one.
16.
And one more.
20.
So today, or the other day, we worked with factors. We had to find greatest common factor. So we had to list the factors of two numbers and find the one they shared that was the biggest. Today, we're going to be working with multiples. So please make sure that you are working with multiples, not factors. If you start listing factors, the lesson's not going to go so well. Mason, please read the sentences under the title, loud and slow.
To compare factors, create equivalent fractions with the same denominators or the same numerators. Use the least common multiple or the least multiple common to two sets of multiples.
So, least common multiple is the least multiple that is common to two sets of multiples. So it's just like greatest common factor, except instead of factors, we're working with multiples, and instead of the greatest, we're looking for the least. What does least mean? What's a synonym for least? Michaela? Less, or what can we use instead of saying least common multiple? We could also say, Zadie?
Simplest.
Not simplest. Smith?
Smaller.
Smallest, not smaller. Less and smaller go together. Least means the smallest, so we have to use smallest common multiple. So what we're going to be doing is we're going to be taking two numbers and we're going to be listing multiples until we find the least common multiple. So the smallest one that they both have in common, that they both share. Sometimes we're going to have to list the multiples for 3 numbers, and we'll see that later. So, everybody, finger or pencil on example 1, and you'll see what we mean. Please don't make me repeat myself. Okay, read in your head while I read out loud. Every period, we're going to visualize. Ramon has an insect collection. Okay, I'm imagining insects in jars with holes in the top. The table shows the lengths of 4 insects in his collection. Okay, that tells me these fractions right here are how much of an inch each of them are if we measured from here to here. Which is longer, a mosquito or a whirligig beetle? Well, let's look. We have a mosquito, which is 1/4 of an inch, and we have a whirligig beetle, which is 3/8. Okay, we could use our fraction tiles, but are we going to have our fraction tiles everywhere we go? No, so we need to figure out another way to do this. Step 1 is we have to find the least common multiple of the denominators. So, we know a mosquito is 1/4 of an inch. What is the denominator in 1/4? Class? 4.
4.
We know a whirligig beetle is 3/8 of an inch. What's the denominator of 3/8? Class?
8.
8. Now, we had those tips that we learned yesterday where, oh, I forgot, we had a anchor chart. Let me pass out this anchor chart really quick. Look at the tips in the middle with the purple title that says same numerator and the green title that says same denominator. We wrote these down yesterday. We know if 2 fractions have the same numerator, then the smaller denominator is the greater fraction. That's that one that's backwards. If the numerator is the same, the smaller denominator is the greater fraction. If the denominator is the same, then the larger numerator is the greater fraction. That made sense. That's the one that makes more sense. Because, let's look at 3/4. Oops, hold on. We have 3/4. And then we have 3/6. Well, they have the same numerator, but remember, the smaller denominator is the larger fraction. We can see that even though their numerators are the same, and you think the smaller denominator would be smaller, that's not the case. If the numerator is the same, then the smaller denominator is the larger fraction. We can see that. 3/4 is a lot bigger than 3/6 because 4ths are broken into larger pieces than 6ths. If we have the same denominator, now I'm going to do it with a different one than they did because I don't have enough. Well, I can just change it up just a little bit. We have 3/5, and we're going to do 2/5 instead because I don't have enough to do more than that. So say we have 3/5 and 2/5. We have the same denominator, but the fraction with the larger numerator, that 3/5, is larger than the one with the smaller numerator, 2/5. So these are tips you have to do what with? Cullen? Memorize. If it has the same numerator, the smaller denominator is larger, is greater. If it has the same denominator, the larger numerator is larger. So make sure you remember that. Can we use either of those tips to compare 1/4 and 3/8? Do we have the same numerator or the same denominator in those 2 fractions? No. Come on, guys, wake up. We have 1/4, and we're comparing it to 3/8. Their numerators aren't the same, their denominators aren't the same. So we can't use those tips. Remember, if I'm writing it on the board, you're writing it in your book, unless I say otherwise. Please don't make me have to say that. They don't have the same numerator, they don't have the same denominator. So we can't use either of those tips. We can't use the same numerator tip, we can't use the same denominator tip. So what we have to do is we have to find the least common multiple of the denominators. So we're going to start with the multiples of 4, and we're going to start listing them. We're going to leave off 0. Even though we know 0 is a multiple of every single number, we're going to leave off 0 because it wouldn't make sense to use that as our least common multiple. So the first 4 multiples of 4 are 4, 8, 12, and 16. Then I'm going to go ahead and list 4 multiples of 8 and see if they have any in common yet. Multiples of 8 are 8, 16, and 24. Now we're looking for the least common multiple, the smallest multiple that they both share. Class, what is the smallest multiple that they both share? 8. The least common multiple of the denominators is 8. So now, we're not done yet, because that still doesn't really help us. What we have to do is we have to create an equivalent fraction for one or both fractions that has 8 as a denominator. Are we going to have to create an equivalent fraction for 3/8 that has 8 as a denominator? Why? Do we have to create a fraction, an equivalent fraction for 3/8 that has 8 as a denominator? Come on, guys. Zadie.
Yes.
Why?
Because it says we have to use 8.
But 3/8 already has 8 as a denominator. So why would I have to create another fraction with 8 as a denominator? I'm trying to get my fractions that I'm ordering or comparing to have the same denominator. I need them both, in this case, to have a denominator of 8 because it's the least common multiple. So do I have to change 3/8 so that it has a denominator of 8? No. It already has a denominator of 8, so I can just leave it alone. But 1/4. Do I have to change that one in order for it to have a denominator of 8? Class?
Yes.
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 So that means I need to figure out, okay? 1/4 will equal a fraction with 8 as a denominator. So this is where I'm doing what we did the other day in our independent practice, where I know the denominator. So I need to figure out what did I do to my first denominator to get to my second denominator, and then whatever I do to the denominator, I also do to the numerator. So I started with 4, and I ended up with 8. Well, 4 times 2 equals 8. If I multiply the denominator by 2, I also have to multiply the numerator by 2. 4 times 2 is 8, which is my new denominator. 1 times 2 is 2. So there's my new numerator. Oh, I forgot to scroll. So hold on one second. Now we know that 1/4 is equivalent to 2/8. Now they show this, we don't have to do that because we already know anything times 1 is itself. So if we multiply the numerator and the denominator each by 1, we're going to get the same thing. So we don't have to, we can skip that step. If a fraction already has a denominator that is your least common multiple, just leave it. Don't worry about it. Now we're comparing 2/8 to 3/8. Let's look at our anchor chart. Do these fractions have the same numerator or the same denominator? Aaron? It's an either or, which means I'm not looking for yes or no. Do they have the same numerator or the same denominator? What do they have? They have the same denominator. So let's look at our anchor chart and find the same denominator. Clue. Tip, not clue. It says the larger numerator is the greater fraction. So out of 2/8 and 3/8, 3/8 has the larger numerator. So it is greater. But now we're not done because we have to answer the question. Does 2/8 is less than 3/8, answer the question, which is longer, a mosquito or a whirligig beetle? No, we need a word, right? We need, okay, which one's longer, the mosquito or the whirligig beetle? Well, we know the mosquito was 1/4 of an inch, which is equivalent to 2/8 of an inch. And the whirligig beetle was 3/8 of an inch. 2/8 is less than 3/8, so the whirligig beetle is longer, sorry. So, steps to comparing or ordering fractions. Write it down here. Step 1, find LCM. What does LCM stand for? Carla?
Least common multiple.
Least common multiple. So we find the least common multiple. Step 2, not find, create equivalent fractions. I'm making it short so you can fit. Create equivalent fractions. Does everybody understand this means create equivalent fractions, not create equals fractions? If you don't understand, then maybe write out the word. Create equivalent fractions. Then step 3, compare numerators, which you can use this same denominator tip on your anchor chart to help you. So what you're doing when you're comparing and ordering fractions is you are creating 2, in this case, or 3, if you're ordering fractions with the same denominator. That way, all you have to do is look at the same numerators. Whichever numerator is greater, that's the fraction that is greater. Whichever numerator is smaller, that's the fraction that is less. Zari, did you have a question?
The board is blurry and I'm not able to see the steps.
Okay, so step 1, just listen, okay? Because you know how to spell all these words. Number 1, find LCM. It's an abbreviation. So it's all LCM is all capital. You'll see LCM through high school and maybe even college. So now you'll hopefully remember. Oh, I remember 4th grade. Zari, do you have step 1? Step 2, create equivalent fractions. Step 3, compare numerators. Okay, so does everybody understand? So yes, you will be listing multiples. However, you do not have to list every single multiple. Would you be able to list every single multiple for every number? Do numbers ever end? So can we ever finish writing multiples? No. What you're going to do, I think we might see that with number 2, is start with the first 4 multiples of each. Usually, not always, but most of the time you'll find a least common multiple within the first 4 multiples. If not, list 4 more for each. So do you understand what I'm saying? We started with 4, and then we looked. If we don't find one, do 4 more, and then look again. I think we'll see that with example 2. I can't remember. Okay, go ahead and go to turn the page. Carla, did you get the new example 2?
Yes, I did, and I put it out and couldn't.
Okay, so go ahead right now while I am switching, because I have to switch from the book to the PDF of it, the picture of it. Go ahead and tape it or staple it. Okay, so the reason I gave you this printout and just completely covered up the example 2 in the book is because example 2 also told us how to change the numerators so that they were the same. But I feel like there's no reason to do that. Yes, you can change your fractions so that they have the same numerator. Excuse me. But a lot of times that's going to take a little longer, and it's also just confusing to have to go back and forth. Also, it's confusing because look at what happens with the same numerator. That's that that confusing one where it says the smaller denominator is the greater fraction. I feel like that gets confusing because it doesn't sound like that's what it should be. It's true, the smaller denominator is the larger fraction if the numerators are the same, but it's confusing to a fourth grader. So that's why instead of changing the numerators so that they are the same and then comparing the denominators, we're just going to do the same thing we did in example 1. We are going to change the fractions so that they have the same denominators, and then we're going to compare the numerators again. So, everybody, finger or pencil on your new example 2. That if you are at school, it is taped into your book, and if you are at home, you have hopefully taped or stapled in. If you would like me to tape it more because you feel like it is not safe in there, let me know and I'll do it while we're doing independent practice. Okay, read in your head while I read out loud. Remember, when we get to periods, we're going to visualize. The table shows the cooking times needed for different foods. Okay, so my table tells me that rice takes 1/4 of an hour to cook. Lasagna takes 5/6 of an hour to cook. And enchiladas take 2/3 of an hour to cook. Order the foods from least to greatest cooking times. So we're going to put these 3 fractions in order from least to greatest. But right now, are we able to use either of our tips to put them in order? Do any of them have the same numerator or the same denominator? No. Look at your book, not me. I'm not the one, the answer's not here on my face and it's hard to read up here. So look in your book. Do any of those 3 fractions have the same numerator or the same denominator? No. So we need to change them so that they all have the same denominator. So what we're going to do is we're going to list the least common multiple for all 3 of these denominators. We're going to find the least common denominator of 4, 6, and 3. So let's start by listing the first 4 multiples of each one. The first 4 multiples of 8 are 4, 8, 12, and 16. The first 4 multiples of 6 are 6, 12, 18, and 24. And the first 4 multiples of 3 are 3, 6, 9, and 12. Yes?
Do you just want us to write myself?
What do you think? Yes. Okay. So now let's look. Let's see. Can we find a multiple that they all have in common? 6 have 6 and 6, but does 4 have 6? Nope. What about 12? They all have 12, and it is the smallest multiple they have in common. That means we have to change all 3 fractions so that they are equivalent fractions with 12 as a denominator. So we're going to start with the rice. We know it takes 1/4 of an hour. We need to find an equivalent fraction with 12 as a denominator. So all we do is we think, okay, 4 times what equals 12? Class, without looking, 4 times what equals 12? 3. Whatever we do to the denominator, we also have to do to the numerator, right? That never changes. Anything we do to the denominator, we also do to the numerator. So since we multiplied the denominator times 3 to get 12, we're going to multiply the numerator times 3 to get 3. 1 times 3 is 3. So rice is equivalent to 3/12 of an hour. Now lasagna, it takes 5/6 of an hour, but we have to find an equivalent fraction with 12 as a denominator. So what do we do to 6 to get 12? 6 times what equals 12, class?
2.
2.
Whatever we do to the denominator, we also do to the numerator. So 6 times 2 equals 12. 5 times 2 equals
10.
10. So now we know lasagna is equivalent to 10/12 of an hour. Now we have to find enchiladas. The table tells us it takes 2/3 of an hour to cook, but we need to find a fraction with 12 as a denominator. Class, 3 times what equals 12?
4.
4.
Whatever we do to the denominator, we also do to the numerator. So class, 2 times 4 equals
8.
8.
8.
That means enchiladas are equivalent to 8/12 of an hour. Now, we have 3 fractions with the same denominator. So we can use this tip. If the denominator is the same, the larger numerator is the greater fraction. So let's look at our fractions. We have 3/12, 10/12, and 8/12. We need to list them in order from least to greatest. 3/12, 10/12, 8/12. Which one has the smallest numerator, class?
3/12.
3/12.
12.
Which numerator comes next? 10/12 or 8/12, class?
8/12.
8/12.
Which numerator comes next, class?
10/12.
10/12.
But the question says, order the foods from least to greatest cooking times. Are these fractions the foods? No. So we have to figure out, okay, the one that takes the least amount of time is the fraction that's equivalent to 3/12, which is the rice. Come on, guys. Confidence. Look at your table. If you did what I did, you already have that. Now the food that takes the equivalent to 8/12 of an hour is
Enchiladas.
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 And the food that takes the most time, the one that's equivalent to 10/12 of an hour,
Lasagna.
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 Now the next part says check with models, which we can't see here, but that's okay. I don't know if I'm doing this in the right order, but oh well. Try to be good. Now I know these aren't exactly equivalent, but you know. So 1/4 means we only shade in 1/4 of our shape. 2/3 means we shade in 2 out of 3 of our pieces. And 5/6 means we shade in 1, 2, 3, 4, 5 of our pieces. And we can see that 1/4 is the smallest. 2/3 is big, but not the biggest. And then 5/6 is the greatest. So you can use models to check. You can use your fraction tiles to check. However, this is how you need to find it. So does everybody understand what we're doing? First, we're finding the least common multiple. Second, we're creating equivalent fractions with the least common multiple as a denominator. Then we're comparing the numerators. Let's try it together on the guided practice. The neater you are, it's a good thing I didn't send it to you guys, I forgot. The neater you are, the easier it will be to find the information you need. So, let's go to your separate sheet of paper. I'm going to go ahead and erase this down. And write number 1. And then use 2 lines for your fraction, okay? So do you understand what I mean? The top line has the numerator, and then you draw a little line over top of the blue line, and then the bottom line has your denominator. You can take up both lines to do your circle, and then do the same thing. The numerator's on the top line, the denominator's on the bottom line. Okay, we have 3/4 and 1/2. Can we use the same numerator or same denominator tip for either of these? No. So that means we need to find the least common multiple. So, skip a line, use a whole line to start listing multiples of 2. So skip a line between, a line or two. Then go to the next line underneath your 2. I like to list the multiples for the smaller denominator first because I'm more likely to find a least common multiple quicker. And then underneath the 2, we're going to find multiples of 4. We're going to start with the first 4 multiples of each. Aaron, what are the first 4 multiples of 2?
4.
Is that the first multiple of 2?
2.
2.
4. 6. 8.
Okay? There's the first 4 multiples of 2. We know there's more, but we're just going to stop at 4. Now let's list the first 4 multiples of 4. What's the first one?
4. 8. 12. 20. Not 20.
Think of your basic facts. 4 times 1, 4 times 2, 4 times 3, 4 times 4, which is 16. Okay, Aaron, do we have a common multiple?
Yes.
Yes, what is it?
4.
Do we have any others?
Yes.
What's the others?
8.
Now, which one's the least?
4.
So we should have underlined, actually. We should have underlined those common multiples and then circled the 4. So that means we need to create 2 fractions with 4 as a denominator. Do we need to do anything to 3/4 to create a fraction with a denominator of 4, Aaron?
No.
No. So, but what about 1/2?
Yes.
Yes, so skip a line. Use 2 lines for your fraction. 1 on the first line, put a little fraction line underneath it, and then 2 on the second line, and give yourself a little space, and then put your equal sign, and we know our new fraction has to have what as a denominator, Aaron?
3.
3?
4.
4. Remember, the point of finding our least common multiple is to figure out what our new denominator needs to be. Now we have to figure out, okay, what happens here? What do we multiply or divide by? 2 times what equals 4?
2 times 2.
Do we do something different to the numerator?
No.
No. Whatever we do to the denominator, we also do to the numerator. 1 times 2 is?
2.
So that means 1/2 is equivalent to
2.
Now, they have the same denominator. So we can use our tip. Aaron, if they have the same denominator, which numerator shows if it's greater? The larger numerator or the smaller numerator? The larger numerator. So which one has a larger numerator? 3/4 or 2/4? Which means 3/4 is greater than, less than, or equal to 2/4. Greater than. So now we're going to go over here, and we're going to say that 3/4 is equivalent to is greater than 1/2. So does everybody see what we're doing? Now, draw a line, or a squiggly line, underneath number 1, and we're going to set up number 2 in the same exact way. So underneath your squiggly line, go ahead and write number 2. And I'm going to write this here for now, but I'll erase and move it up. But this is what it'll look like. Number 2, we're comparing 3/6 and 3/4. So we're going to write 3, our numerator, right under the squiggly line. Take up a whole line for that. we're going to draw a small fraction line over top of the blue line on the paper. And then we're going to put the denominator 6 on the next line underneath. We're going to make our circle take up the whole line. And we're going to write our next fraction, 3/4, the same way. 3 is going to take up the whole top line. We're going to draw a small little fraction bar over top of the blue line. And then we're going to write, take up a whole line for our denominator. Now I'm going to erase this and go up here so that everybody can see. So does everybody have this so far? And you know you're going to skip a line to start listing multiples. Zadie, I know that we can use the same numerator tip, right? But we need the practice. So let's go ahead and follow the steps. Find LCM, create equivalent fractions, compare numerators. So we're going to skip one line or two. We're going to skip one or two lines. We're going to go to the next one. And we're skipping one or two lines, and then we're going to take a whole line. Remember, I like to do the smaller numerator denominator first. I don't know why, it's a personal preference, I guess. We're going to take up one line to list the multiples of 4, and then we're going to go to the immediate next line so that we have a place to list the multiples of 6. Zadie, when you're ready and you have that written, let me know. Okay, Zadie, let's list the first 4 multiples of each of these numbers. First 4 multiples of 4. 4,
8,
8,
12,
12, 16. Now we need the first 4 multiples of 6.
6, 12, 18, 24.
Remember, basic facts are so important because all you're using are basic facts. 4 times 1, or let's see, number times 1, number times 2, number times 3, number times 4. Do we see any common multiples?
Yes, 12.
What are the common multiples?
12.
Do we have any others?
No.
So we know no matter what, what's our least, our smallest common multiple?
12.
12. So that means we have to create fractions with a denominator of 12. Is 3 6? Do we have to change that so that it has a denominator of 12?
Yes.
Yes. So skip a line or two. Write your 3 6, taking up 2 lines. And we know our new denominator has to be what, Zadie?
It has to be 12.
It has to be 12. So let's think. What do we do to 6 to get 12, Zadie?
You multiply it by 2.
Multiply it by 2. Do we do something different to the numerator?
No.
What do we do to the numerator?
You multiply it by 2.
And 3 times 2 is?
6.
So that means 3 6 is equivalent to
6, 12.
3/4. Do we have to change it so it has a denominator of 12?
Yes.
So let's do the same thing. You can do it, like you can go to the side. You can go next. Since we're doing the same thing, do you see we're kind of showing our steps here. Here's step 1, find least common multiple. Here's step 2, create equivalent fractions. And then step 3, comparing the numerators. We'll go back to the first line. So we're starting with 3/4. And our denominator, our new denominator has to be what, Zadie?
12.
12. Now we have to figure out, okay, what did we do to 4 to get 12?
Multiply it by 3.
We multiplied it by 3. I'm going to give you a hint. This lesson, you're only going to be multiplying. You're not going to be dividing here. No, you won't be dividing. Because if we're finding multiples, it's going to be bigger than all the numbers, right? What do we do to the numerator?
You multiply it by
3 times 3 is?
9.
So that means 3/4 is equivalent to
9, 12.
9/12. When you're on your separate sheet of paper, you are 100%. You should be erasing what you have here and replacing it with what you've made. Then you can see you're replacing it. You're changing it. Yes?
Is it okay if you put an arrow beside it and then
Instead, I don't know. No, I think you guys need to erase. I think you need to see the difference. Okay, Zadie. So now we are comparing 6/12 to 9/12. Now we can use our same denominator tip, which is really easy because it's exactly as we would think it would be. The larger numerator is the greater fraction. So 6/12 or 9/12. Which one has a greater as a larger numerator?
9/12.
So that means 6/12 is greater than, less than, or equal to 9/12.
Less than.
Less than. Which means that 3/6 is greater than, less than, or equal to 3/4.
It is
Remember, same, same. So if 6/12 is less than 9/12, then 3/6 is less than 3/4. That's another reason why it's so important to make sure that you're writing it correctly on your paper. So that you can literally go, okay, first fraction, what is it? Second fraction. Okay, we only have 5 minutes, so this is what we're going to do. I wish we didn't have to do this anymore, but we've got to get through reading so we can take our quiz tomorrow. So we're going to do the independent practice for this lesson tomorrow. But you will have some work to do tonight.